Yo, 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 everyone. What's going on? Okay. Hey. Okay. So I got a hint on this problem because I was just, oh my God, after last night, I was just completely stuck. So the hint was basically, I don't know, the way that we've been going about it, we've kind of been thinking, oh, okay, so like the first value that we want to print out is 2. So we need to so basically like the value before needs to be such that when you modify A, it'll be 2. And then like B, like 2 needs to be this. Like B3 needs to be this, and B2 needs to be this, and B1 needs to be this, and like A needs to be this to print out a 1. I guess kind of the problem with that is A is very like underdetermined. You get this like equation with not like, I don't know, like interlocking terms or something, but you get all these A's and you just wind up with something that just looks like, I don't know, you just can't really do much with it, and you're not much better off than you were when you started. It doesn't tell you something that useful. But the way that my friend solved it, which I saw, was kind of thinking about, all right, let's go from like the end and kind of like work our way backwards. So it's almost like maybe what do the last 3 digits need to be? I guess in A to basically like print out a 0. And by the end of this, you need A to also be 0 as well. So maybe it's kind of like starting with this last line here, which is like, all right, so A needs to be 0. And just for simplicity right now, let's just forget about these XORs because they're just kind of like adding noise. So we've got like B1. So like let's just call this C. let's say that the new value of A goes into this. Yeah, I guess we'll do A1 and A2 because it actually is something that gets updated. A1 has to be this, and B, this is just B1 and B2, and B2. So basically it's like this, it looks like. Actually this should be A2. So you kind of start all the way down here and say, all right, well, for this program to terminate properly at this point, like A2 needs to be 0. And this is very determined and very definite and very constraining on A. We kind of start from this point, and hopefully the way to expand it, I guess, will be a lot clearer. So basically, if A2 is 0, then we will terminate this program. The next thing we need this program to do is we need it to be such that when you take B2 and you mod it by 8, you get you get 2. If this is the case, then you will print out 2. And let's like further constrain B2, because like we know that B2 kind of comes from, like, we know that B2 is going to be bounded between 0. Well, I guess not necessarily, because we're doing this XOR thing with C. I don't know. I guess let's just keep going. B2 basically has to be of this form, where it's like XXX blah 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 010, like this. Basically, like the last 3 digits of B2 have to be that. So then we kind of take, okay, so we say, so we're kind of like trying to go backwards. So we know that A2 is equal to A1 shifted over by 3, and that thing has to equal 0. So in my mind, I'm just imagining right now A1 basically just has to be like a 3-digit number. It basically, yeah, it basically has to be some function of 2. It basically has to be like 2 is kind of like what I'm thinking. So I guess from this, you can kind of say, like, if A1 has to be, A1 bit shifted by 3 has to be equal to 0, you could basically say that it follows that A1 has to be greater than or equal to 0 and less than or equal to 7. Because if A1 is greater than 7, then it being bit shifted by 3 is not going to be equal to 0 anymore. So you've got this. So so now you've got B2 mod 8 has to be 2. B2 is equal to B1 XORed with C. And when you mod this thing by 8, this thing has to give you 2. And kind of working our way up here, we have that B1 is equal to A1 mod 3. It shouldn't be 3, actually. It should be 8. Yeah. So we have A1 mod 8. This thing XORed with C, which is A1 bit shifted by B1. This thing mod 8 has to be equal to 2. And kind of doing this one more time, like you say A1 mod 8 XORed with A1 shifted by, so what is B1? That's A1 mod 8 and this whole thing mod 8 has to be equal to 2. So if that's true, can we is this any better than last time? I think it is because we had this constraint, I guess, that we're propagating up. Oh yeah, I guess we can kind of apply that. So you know that A1 is between 0 and 7. So it's like, what are the values of A1 that are going to satisfy this? You can find that. You can just search over 7, and then yeah, you can just take that value to be A1. I guess the question is, are there going to be multiple values of A1 which satisfy this? We can kind of do it out forwards and kind of just see what it needs to be. Like we kind of see that maybe just kind of intuitively, let's just try some values and see if we can get something to work. So, all right, let's also just do the input. So what if we said that A1 was just equal to 2? Then what do we have to do? Then we say B1 is equal to, yeah, it's just the last 3 bits. So that's good. And we say that C is equal to A1 bit shifted down by 2. So bit shift this thing down by 2. So C is 0 in that case. So then we say B2 is equal to, yeah, these two guys XORed together. And so this is just 010. And so then we say that A2 is just this thing shifted over. So A2 is going to be 0. And so then we do 2 bit shifted over by B2. Oh, mod by 8. That's going to be equal to 2, and that goes out to the screen. And then we check the value of A2 and it's 0. So like we're good and we finish it. So let's just write some code and let's see if any other value of A would work. Recall A has to be less than or equal. It has to be between 0 and 7. So let's just check all those values and let's just see if any of those other than 2 work. Okay. Let's see. So let's kind of go forward. So let's just start a new thing, I guess. Let's say for A in range 0, in range up to 8, we'll say B1 is equal to A. Okay, we'll say A1. A1 mod 8. We'll say C is equal to A1 bit shifted over by B1. And we'll say B2 is equal to B1 XORed with C. And we'll say A2 is equal to A1 bit shifted over by 3. And then we'll say B2 mod 8. Maybe like out is equal to this. And then we'll print A2. I guess we can, let's just do this for one value of, let's say A1 is equal to 2. And so we print out, and maybe we could also print like all these values. So we print A1, B1, C, B2, and A2. Maybe we can kind of do them as like a dictionary instead. So like A1, A1, B1, C, B2, A2. What's the error? A1. Oh. End of line. Okay, so for key value in okay. So A1 We can do it like this. I don't want to print out like print A1 and A2 next to each other. Maybe like this. B1, B2. Print C. Maybe something like this. Maybe it's like A is equal to and maybe B is equal to C is equal to 0. Be something like that. I don't know. Maybe tracing it out is better. I think it's like print. And so we do this, we print. We can do this. I kind of want to see A2 at the bottom, I think. That's like the next iteration, the next run. So I guess we kind of have that. It's like this thing. And B2. I guess we almost have like this B1. It's almost kind of like this. You start with A1 and then you get B1 and C from that. And then from B2, you get like A2 is equal to 2. It's kind of like that. You're starting off with A1 and then from Maybe that's okay. So now maybe we could say like for a1 in range up to 8, let's just do all this stuff. And down here, let's do okay. So we got an out of 0, out of 1, out of 2 when a1 is equal to 2. That's good. Out of 3, out of 4. Yeah, because when we just did 1, we got c is equal to 0. Recall that we are shifting a by b1. Okay. So it seems like we just got out like 1, 2, 3, 4, 5, 6. So it seems like it seems like we're kind of fixed on what the last value of a is. It seems like at the very end of this, like right before this iteration, we need it to be that a is equal to 2, like for this thing to work. Basically, a is equal to 0, 1, 0. That's like the only way this can work. So now let's see if we can go like one step like backwards from this. So let's see if like a, for instance, is equal to it kind of has to be like 3. So it's like 0, 1, 1, I guess. And so we can kind of, let's see. What if a was 0, 1, 1? This is basically like the 3, and it's 0, 1, 0. This is like the 2. And so let's just play this forward and let's see what would happen here. So a is equal to this. So b1 is just going to be, like these 3 bytes. It's like 0, 1, 1. C is going to be equal to a1 bit shifted over by b1. So so we take a1 and we bit shift it over by 3 in this case. That's, well, we'll see. Okay, so we bit shifted over by 3. A bit shifted over by b1, which is 3. Okay. And you're just going to get this basically. C is going to be equal to 0, 1, 1. So we're going to do b2 is equal to b1 XORed with C. And that is going to give us 0, which is not what we want. Like we wanted to output 3. So let's instead of trying to reason our way through this or whatever, let's just loop over what those values can be. So basically, yeah, so we're starting off with A, and we know that the last 3 bits have to be 010. Those are like fixed and we're good. But now we have to loop over for like the next 3 bits. These have to loop from 0 to 7. So let's see if there can be multiple solutions or there's just one, and I don't know. I guess we'll see. So this is 2 here. So this is 2 to the 0, 1, 2. This is 4, 8. So I'm just wondering how we actually do this. Like we have to loop over from these being from 0 to 7. Maybe we can do this in kind of raw binary where we do loop over those and then we concatenate it. What's the best way to do this? Yeah, I feel like it is kind of looping from 0 to 7, and we just have to kind of like we have to convert that to binary and then convert the 2 to binary, concatenate them, and then do it back into decimal. So, through ChatGPT, how do we convert decimal to binner? So we do the bin. How do we chop off the? Yeah, okay, let's chop off this thing. Two onwards. Okay. Format. Yeah, okay. So we want to get the decimal number of 0, for instance. It's okay. So we're basically going like for I in range up to 8. And our decimal number is this. And we're just saying like I. Yeah, those are all those things. And then we also want to do a bin of 2. Just see what that looks like. Okay. 2 onwards. And so we basically want to add the 2 on there. Oops. And let's say we've got num. Well, okay, I guess we have A1. Print the A1. So we've got that. So this is basically, yeah, it's always a 2 on the end, and we're looping from 1 up to 7. So now do we convert from binary back to decimal? Int. So we'll say binary A1 is equal to this. And we'll say int. Say this is A1, and we'll just print A1. And those just happen to be the numbers. So let's, yeah, I mean, I guess we can just basically kind of do this. And let's see what happens. Let's see what they print out. Let's see what gets printed out. A1. Yeah, so it starts off at 2. So the out is 2. Like we want the out to be 3. So like that's not going to work. Let's see how many get 3. Out is 6. That's not going to work. Out is 0. That's not going to work. We need a 3. Out is 6. Out is 6. Out is 6. Out is 4. Out is 6. Is this impossible? Yeah, it seems impossible. Now I say that, but let's bring back in those XORs, because like maybe it's possible with XOR, but it wasn't possible just like with this. So let's bring back this thing. So basically 8. So basically have this. A1 is equal to 0, say. So now we say, all right, B1 is equal to that. And we say B2 is equal to B2 is equal to B1. No, so B1 is still this, and we say B2 is equal to B1 XORed with 5. And I guess we can print out B1 at this. We get B2 and we get C1, I guess kind of in parallel. No. No, we just get B2 right now. Now we get C is equal to A1, but shifted over by B2. And I guess we just print out C at this point. B2 gets fed into that to get you C. And then, so now we have B3 is equal to B3 is equal to B2 XORed with C. So B3 and A2 is this. And now we want B4 is equal to B3 XORed with 6. And this is, the out is this. So, and we also want to print out B4. Okay, and then A2. So basically, at the top, we want to print A1. So we have A1, B2 is equal, we didn't print out B1. What happened to B1? Do we want to print out these in binary too? Like maybe this would be better to print out in binary. Binner. How do we, yeah, maybe doing the format thing would be better. ChatGPT was right. Using format. How do I do a format string with the curly braces for printing out a binary number? This thing with B. It's A1 as B. Okay, so this is B1 now. B2. Two is 101. Oh yeah, because we're XORing it. So now we say C is equal to now we say B3, we're printing that out. And we also want to do it with B4. And I guess finally we want to do it with A2. We don't want to do it without though. Okay, so we got a 3 for the out. So yeah, let's loop over from, so that's looking good. So let's loop over from 0 to 7 and see, let's see, for A1, range 8, let's just see. So we got an out of 3. So we want an out of 0, right? Yeah. Why did I say we wanted an out of 2 to begin with here? Like we actually wanted to print out a 0, so I'm confused. So like okay, so we got an out of 3, 2, 1, 0 here for this value, which is good. Out, 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 out. Okay, so it seems that this setting of A1 was the good setting. And for A1, I kind of want to think of it in terms of 3 bytes, and B1, I also want to think of it in terms of 3 bytes. So ask ChatGPT, how do I left pad a binary string with zeros to grow it to length 3? zfill, an f string. We could do 0, 3, b like that. We're printing out A1 up here. And then B1 is also 0, 3. Okay, that's cool. Thanks, ChatGPT. So basically, yeah, A1 should be thought of as 3 for right now. B1 should always be thought of as 3. B2 should always be thought of as 3. C should not necessarily just be thought as 3. It should be thought of at least 3. B3 is like, I don't know, who knows, we'll see. A2, not necessarily. Again, I guess at least 3, but whatever. The out thing, yeah, I don't know. Let's just see with that. Let's see where we're at. A1, B1, B3, B4. I guess let's just do it on B4, like to get it to be at least 3. And then A2 is 0, I guess, in that case. So C, all right, fine. Let's do it at least 3 again. All right, so we found the value of A such that it will, that will get a 0 and A2 will be 0. This is the only value where that's the case. So now we need to loop over the next 3 things. So say for I in range 8, we want to do this thing again that we had kind of down here. The binary A1 is equal to this thing, like, yeah, this was the value that we found. Yeah, for this one, so let's just print the binary A1 right now. Let's just see what it looks like. So 0, 1, 1, and yeah, so we appended a 0, so that's good. And then we do a 1, and then yeah. And let's do a zfill kind of thing on this. So we've got the binary string and zfill.3. dot cfill. How about that? So we've got, yeah. And what if I just did this too to make it more clear? So yeah, we've got this number for the second one, and then we loop up through 7. So that looks good. So then we just have A1, and let's print A1 and see. Yeah, I guess these are the values that we're going to test. And let's see if any of these output a 3. So basically, for I in range 8, we do this, and we basically do this and see if we get any outs of 3. Out of 0, 0, 0, 0. Why are all these zeros? I feel like there's something wrong here. Wait, why is A1 just... Oh, okay, A1 is just 2. A1 is 1. Okay, then A1 is like this thing here. Why are all these out of 0? I don't understand. So we start off with, let's print out A1. It's do this by 6 basically, because that's how we're thinking about it. So we do it with zeros. Oh, we want to okay, we actually want to append it on the end. I'm appending it to the left, but we should append it to the right because A1 is going to get crunched down. So we want to crunch, we want to be crunching that bit off. So we kind of actually want to do this instead. Kind of like this. So we kind of want to do this to where we're trying these values, and yeah, well, once we like crunch these off, we're going to get to this level here, and like we're going to print out a 0 basically. So we do want to try these, and let's see what happens. Print. Okay, so, okay, cool. So we got an out of 3. Okay, we got another out of 3. Got an out of 0, an out of 1, an out of 3, another out of 3. 4 outs of 3. Dang. Okay. All right. I mean, we're gonna see whether this is doable or not. Like how many branches we're gonna get. Like hopefully the branches are not gonna be. Hopefully we're not gonna get a lot of branches. Because yeah, if we do, this is gonna take way too long. There was 4 branches here. It's getting a little dicey. I think this is 16. I think this is 16 in total. So, if we're at like 2 to the 16, we're good. This is like 2 to the 10th times 2 to the 6th. This is just like 1,000. 1,000 times 3264. So this is like 64,000, which is like completely fine. We can kind of like print out some of these to see what the highest branching factor we can support is. So what's like 3 to the 16th? 1, 2, 3. 1, 2, 3. Dang, that's 43 million already. So, I mean, that's kind of like right on the edge. So, if our branching factor is kind of like on average around 3, then I think we're going to be okay. But if it's like averaging 4, like if it was just 4 every time, like 3, 1, 2, 3. So this is a billion. So this is still doable. So I mean, this in Python would take a billion. It might take a minute or two, or like 2 minutes, but this is really the upper edge. Maybe we could do another higher factor of that, but yeah, I mean, I guess we'll see. Like, dang man, we really need to steal our resolve right now. Let me just take a second and go back to this one post that is very in my hour of need, when my resolve wavers, I bring up this post right here. I bet he didn't even care to output a periodic message to confirm his brutal code progressed onward and not just got trapped in an endless loop. He just gazed straight into the black void of the console, his brutal heart full of faith, until the solution inevitably manifested itself after a finite period of time. So when I feel my resolve start to waver and I get a little scared, just think of this post and things are going to be all right. So, dang, I don't know. We'll see. All right, so the process here is like this backtracking kind of approach where, on the first one, we took it to be, we found it to be 0, 1, 1 was the one value that worked. And so with this value of 0, 1, 1 here, we tried these values. And so these values worked. 0, 0, 0 worked. That output of 3. 0, 0, 1 worked. That also output a 3. 101 worked. And then 111 worked. So what we basically need to do in each of these branches is we need to construct we need to construct the string basically like let's just take this one for example. So we just take like 0, 1, 1 and append 0, 0, 0, and we we just run this through, and like we know the result of this is like these are going to be chopped off, and this is going to be what's remaining here. And so we just need to run this through and see if it outputs 3 in this case. And if so, like that's good. But yeah, the basic thing is so we're trying a new thing. We have like a string that we know works so far. We have a desired output that we know we need to match. And so we have to do this backtracking thing where we construct this string where we append our new candidate onto the end of the string that we know that works like so far for this, and then we run it through and we see like does it output the thing, so let's see if we can code that up. And you know what? I don't know if I'm going to code that on stream. Maybe should I try? Am I more in kind of like execute mode right now? Can maybe code. We'll see. Okay, so let's say like we have the string that works so far, and this is like, and we'll say the candidate string is equal to, for example, like this one right here. Like, does this work? So what we do is we take the string that works and we concatenate it with the candidate string, and we have the I don't know, call this like the full string or something. And let's abstract out this function into something that actually like computes the function. So it's basically just like one run of this function. Let's just call it, f, and it takes an A1 and it computes a B1 and it computes a B2 and it computes a B3 and it computes an A2 and a B2, and it computes an out as well, and it just returns the out. How about that? Yeah, how about that? So for instance, let's convert let's say A1 is equal to the full string. Let's say f of A1. That's going to give us a 3. That works. So it's kind of like the first version of this. It's kind of, I guess, the kind of like recursive, the kind of like try all the paths version of this is like, this is going to be kind of like recursive. It's kind of like backtracking. So it's going to be kind of like for I in range 8. I mean, it's going to be basically like this stuff here. But instead we kind of want to use this instead. So the candidate string is just going to be I, basically. I guess it's just going to be this. It's like the bin of I thing. Let's just do Z fill. Why not? The string that works is going to be kind of up here so far. And full string. Yeah. And we have A1, and we'll see if it works. Like, let's do f of A1 out. And we kind of have a desired thing. That's 3. Say if out equal to desired. This is kind of like testing them. Print. Yeah, these are the values of A1. So, yeah, I think I'm gonna go off stream now and not do the next part. Probably try and code up the backtracking thing. So, yeah. Thanks, guys. It looks like we got something here. Let's keep the faith. Hopefully this is going to be fast enough, and see you guys later. Peace.